So what is the purpose of these AI research network? We are trying to build connections across the disciplines. We are highlighting the amazing work done by our scholars at Ilan University. Another important point of this event, apart from the highlighting the work has been done at Ilan University, show and prepare our institution for a future grant process. There are a couple of, interestingly, I will highlight that. Interestingly, we know that national grants are being rejected. There are a lot of issues right now currently, cut it. But AI research grants being increasingly given. Indeed, they just still processing. We had a conversation with last week with some of those consultants, and they just said, we still believe that AI research is going to be supported by federal and other institutions. Indeed, there are a couple of grants that we identify, and last year's more than billions dollars giving different institutions for their AI center, AI research. Indeed, one of the grants just giving $15 million to our neighbors, NC State, and their institution's name, AI Institution for Engaged Learning. When you look at that, you just say, oh, engaged learning, it was our branding. But the question here, why we not collect ourselves, why we are not working together collaboratively applying for these AI grants? Indeed, we had our first AI grant talk last Monday, 2 Mondays ago. Yeah, in that, how many of you joined that meeting? I can see 4 or 5 people, very nice. So if you're still interested in this summer, we are building a team working towards one of those grants. We are going to have a multiple AI grant research teams, and you can just collaborate in whatever and however, role you want to pursue. Second, you receive a lot of email from me this semester. We organized a couple of events. One of them was AI Pedagogy Challenge and AI Show and Tell. It was last week, Friday, just a week ago. And I just want to highlight the outcome of this event. Maybe you attended or not. We received 70 different applications from faculty members. We just grant those people who submitted their idea ChatGPT access provided by Ilan University, and they just developed great, amazing idea. Indeed, what we did, we turned all of those ideas and more to AI repository. Here, I can show to you what we did as Ilan team. This is our Ilan University's website. When you type it, I'm going to show the web page as well, Ilan EDU. You're going to come up with this Ilan Hub. In this hub, there are some resources, AI teams, Ilan GPT, accessible to others, and that is the AI toolbox. When you click this web page, you're going to receive, and you're going to access these generative AI toolbox, curated more than 100 different generative AI custom chatbots. So here, we categorize these chatbots based on different modules or categories. There is AI literacy chatbots. You can click and learn about AI, how to write the best prompt, what are the ways you can integrate and use AI, and what are the ChatGPT use cases for work. There is productivity tools. You can click, you can see that what campus events going on, and how you can just book the best event on campus. There's a flyers makers. There is Ilan branding tools. It gives you suggestions on your design to make the branding align with your, needs. There's an event finders and calendar organizer, custom project management tools, and so on. And I just want to highlight this part, teaching. When you just came back here, these are the ideas submitted by our Pedagogy Challenge people. And you can see more than 80 different AI tools ready to use. If you're teaching strategic communication, there is a tool for it. If you are teaching dance, there is a tool for it. If you're teaching other concept, other topics, there are tools for it you can utilize. One of the goals, we just want to build this repository in the future with instructions and your expertise, those people who bring, and they are going to receive citation. Whoever use these tools, they are going to be attributed those people who contribute this development, and I believe that's going to be very useful, open source to other people to use in their teaching and learning. Please go explore when you have some time. It's very easy to access, I can share the web page again here. Okay, you cannot see here. Let me put it back. So the web page is www.elon/AI, ELON.edu/AI. So in this semester, we organized a series of talk, and we just about to finalize, and we are hosting our final guest today. Final guest joining us from Communication School, Dr. Chris Chen, Assistant Professor of Communication Design. We are very excited to welcome Chris Chen today, Interdisciplinary AI Research Network. AI leading, she is one of the leading scholars in human-computer interaction. Personally, I admire her work. We are cohort, we just started at the same time, and she published more than 9, 10, I don't know, 12 different articles. My record is not like that yet. I'm working hard. There are a lot of things to learn from you. And Dr. Chen's work explored the psychological and societal impact of AI and human interaction, focuses on algorithmic biases, mobile media uses, AI-driven communication, and other. It's hard to list all of them here. Her recent publication examined the trust in AI and user communication. Please join me to welcome Chris Chen.
Thank you so much for the introduction, Mustafa, and it's a great honor to be here to share my research. So, good afternoon, everyone. Thank you for being here. Hope your semester is wrapping up well, and you're going to enjoy your grading and start your happy summer. I cannot wait to get started, so just bear with me with my very, very interesting presentation. I will promise that it's going to be a very fruitful and enjoyable presentation. So this topic is about communicating and combating algorithmic bias, and from a very special psychological perspective. Before I get started, I'd like to briefly introduce myself, because I'm maybe new to some of you here. This is my 3rd year teaching in the School of Communication, and I serve the Department of Communication Design. My teaching focus is on user experience and user interface design, and recently I've been teaching this course called Writing and Researching Design. And back to the time when I was a PhD student, I studied psychology of human-AI interaction, so it has been my 7th year researching in this area. I have been trying hard, as Mustafa was saying, to publish as much as possible. That's because I got a lot of support and resources at Elon University to make that possible. So thank you so much, my wonderful colleagues, and especially librarians who helped me with my research. Thank you so much. And I will communicate myself as an AI researcher and designer because of those interests, like doing research and also trying to design a better interface. But I also want to communicate that it's very obvious here, but I want to highlight I am an Asian woman living in a white dominant society. So this background is really influencing my interaction with AI tools. So I'd like to get started with my personal story, encountering a biased AI system. So that was during COVID time when everything were virtual. As presenters, we're required to record our videos, and the organizers will say, hey, use our tools so you can transcribe your speech into text for transcriptions for the subtitles. See, that's perfect, great, I will use it. But by the time I was using it, I was surprised when I was saying algorithmic bias, and then it translates into algorithmic bias, and then it's just like a lot of errors like that here and there throughout the transcript. And I was wondering, is it just because my English sucks? So I asked my Asian friends, and they say, yeah, we pretty much had a similar experience. Yeah, on the presentation day, I paid close attention to those white professors. Their transcripts were perfect. I'm not blaming them for having perfect English. This is a disadvantage of not being a native English speaker. But what I really want is that I hope this AI system could learn some of my accent or my group people's accent and then be more fair in this case. So that really motivates me to understand this phenomenon called algorithmic bias, which is an unintended consequence of machine learning in which the model favors the dominant group over minority group in its prediction. And it's not just about my case. There are a lot of scenarios where AI shows bias. This is IBM's facial recognition software, and you can see that it had a hard time recognizing darker-skinned females compared to other race and gender. And this is about AI recruiting software from Amazon, and the tool is showing bias against women. So whenever they're reading the resume and they identify words suggesting the candidates may be a female, then they will not let them pass the first round. And the third one is even ridiculous, right? It's just normal people here, a couple labeled as gorilla. You see how biased the AI system is. And of course, Google Photo had made a lot of changes. And nowadays, if you just like search gorilla, then there's no such a keyword anymore in their system. They totally removed it from their system. Yeah, so that's not a good strategy to deal with that, but all these examples is showing that algorithmic bias are so prevalent in nowadays media use, but how do they arise? A quick look into the literature suggesting that bias can be introduced to any stage of this machine learning cycle. But a lot of scholars agree that training data is the primary cause of algorithmic bias. So training data may be a new concept to y'all. I want to give you an example. Like these 4 images could be training data for facial classification, facial emotion like classification AI tools, trying to differentiate happy from sad faces. And usually those photos have to be labeled in this way, like assign a particular values or labels so machine can learn from those patterns. And why I experience bias is likely that the training data the AI tool received is mostly from white people's voice. That's why it had a hard time recognizing voice that is from people in minority communities. And for the AI biased recruiting tool from Amazon, it learns from the historical data. It's mostly about white men getting the job in positions like software engineer. So that's why it is showing biased, like discrimination outcomes against the female candidates. And if you look at the IBM facial classification tools training data, did you see something odd here? Yeah, even though it's just a snapshot of the training data, we can see that most of them are from male and also from light skin colored people, right? So it is like showing bias or lower accuracy when identifying darker skinned females. So that is the thing we're talking about here. If unrepresentative training data can cause algorithmic bias, can lay user understand this logic? That is the research question we asked in our recent conference paper. So to research this question, to understand that, we developed a prototype of an emotion reader AI. We told people that this AI has been trained on a large data set, 6 million faces, and those facial images were labeled by people, happy versus unhappy. And the algorithm learned from those patterns, right? And then we showed them a snapshot of training data. Did you see anything odd from this example? Yeah, I see that. Yes, you probably see that all happy faces are from those white people and all unhappy faces are from black people, right? So that is that's our design. We intentionally made this way to show in the case of unrepresentative label data. In the case that if AI is trained on this type of data set, then the AI is very less likely to identify, for example, happy black faces or unhappy white faces. So it's a biased AI system. We like to show the biased representation of certain racial group. In this case, is the black people in this unhappy classification category. And we also contrast it with an unbalanced condition, with a representative condition. There is no such a confound of race in the distribution or classifications of these facial images. And our hope is that people could tell the difference and believing that the first one will lead to a more biased AI system. And we do find the difference. Yeah, the happy white versus happy black condition was perceived as the highest biased condition, the most biased condition. But the difference was not significant in the sense that people even though there's a difference, people couldn't really infer or really conclude the bias from the system by seeing this example. And instead, they believe like both conditions were worse than the third condition, which is an AI system trained on facial feature. So I'd like to show you an example of what I mean here. Is exactly the same training data set, but we told them that those facial images were classified based on facial features like lip corners pull back indicates happiness, and lip corner pulls downward indicates sadness. So probably people were driven by those kind of knowledge-driven classification. They believe it's more objective and neutral. That's why they believe this condition is the least biased condition compared to the previous two. But that is just one scenario of showing unbalanced training data set. So in study 2, we had another condition, in this case that we didn't even consider other race besides just white people in this example. So that is what we call as lack of representation of certain racial groups in the training data. In this case, there's just no other race included beyond white. So it's white people only sample, and we compare it with a representative one, exactly the same one from our previous study. There is no racial confound again, and we hope people could feel that an AI trained on a biased or unrepresentative label data will be perceived as more biased. So again, very surprising. We didn't find the difference. People still couldn't infer algorithmic bias from the training sample we showed to them. So what's going on? And we did our follow-up study. So in this study, we included all possible conditions of unrepresentative training data, including happy white, happy black, all white, all black. So all these cases are just unrepresentative because it's having racial as a confounding factors and is not representative of these two like racial groups equally in the distribution of these emotion categories. And we compare all these 4 groups with the no racial confound condition, whereas there's just no like issues of race being a confounding factor. And a very special change of this study is that previously we were pretty much focused on like convenience samples on online recruiting platforms. So our participants were predominantly white. And in this case, we changed it. We made the sample like equal across these 2 groups, white and black participants. And we did find some significant results. That is, as you can see here, the happy black conditions were rated as the most biased condition compared to all the other 4. But again, we still failed to communicate algorithmic bias through the other 3 unbalanced conditions. Only one stands out, right? And we have some follow-up questions asking people, did you see anything odd or inappropriate in the snapshot of training sample we showed to you, just as the question asked you earlier? And most people didn't notice that, and only less than 20% people say there is something odd. And among those people, only 23 of them say race is a confounding factor. So they were providing comments like the training sample showed all white faces smiling as happy and crying black faces as unhappy. So they can tell the difference for those who noticed and noticed that race as a confounding factor. And we run a study, we run analysis just to see whether this awareness of confound varied by conditions. So that confirmed our finding, that is, for those who are exposed to the unhappy blacks condition, they are more likely to be aware of race as a confounding factor compared to all the other conditions. And we wanted to see whether this awareness varied by race, and we did find a difference. That is, black people are more likely to aware this unbalanced and unrepresentative training data. And our last research question, open-ended question to our participants is that, do you think the training sample we showed to you was adequate for creating the best emotion reader AI? We're glad that about 44% people say it was not adequate. And when asking about reasons, some people were mentioning about the lack of diversities in the training data could lead to a biased AI system and misclassifying facial images based on their emotions. And we wanted to see whether this perceived adequacy was varying by race. And again, we found that it's about the black people who are more likely to comment that those training data was not adequate to create the best emotion reader AI. So through all three studies, our paper was creating this conclusion that is called confound unawareness, which we mean is that participants have a hard time infer algorithmic bias from a snapshot of training data showing racial confound. But we do find like Black participants in our study, they're more sensitive to a special type of training data, which is just having biased representation of Blacks in the unhappy emotion category. So that is our major finding. And one major reason, yeah?
Can we just go to conditions that you have?
Yes, of course. Yeah, which one?
All conditions, yes.
Yeah, this one?
24.
Mm-hmm.
In these conditions, I was just wondering, because you just saw that there is some heightened saliency based on the demographic group that associated. People just say, okay, you just put all the white happy faces and all the unhappy faces represented by minority groups, and they are very cute and very fast to capture it, aware of it. Did you try to opposite as well? Did you put all the Black people in the happy side, all the white people unhappy side?
Yeah, this is the last condition.
Yeah.
Yes, people couldn't tell, like infer the same level of bias from the last example.
But,
Yeah.
Minority group, look at these two groups.
Yeah, they were randomly assigned to one of these 5 conditions.
And
Yeah.
they just pick both the positive and negative emotional case at the same awareness level or a different level. What I'm trying to say, if an Black person look at both happy face all Black or unhappy face all Black conditions, they were aware the biases at the same level and strength, or there's a differences in the awareness of the biases represented in this training data?
Yeah, that's a great question, but we didn't show participants multiple training data examples. We only showed them one conditions among the 5. So I couldn't tell really from our study whether they are comparing these two and then help them to infer algorithmic bias from the training sample. But we can show that in the between subjects experiment that this unhappy Blacks condition stands out more compared to other unbalanced training data in terms of communicating algorithmic bias. Yeah, but thank you for your great question. And so one of the reasons we believe why it doesn't work is because all these labelings are correct. People may be more motivated to see just how accurate the labeling is instead of seeing how biased the training sample is. That's why it motivates us to answer this question, that is, how can we better communicate training data quality to our users? And in the follow-up study, we focus on this labeling aspects, which is a process of assigning predefined labels to data points. So I'd like to give you an example here. This is a real data annotation screenshot I got online. If you look at the left-hand side image, you can see that the man was happy and he was labeled as happy, which I believe we all pretty much agree about. But how about the young man on the right-hand side of the picture? How would you label it if you just use one word to describe the emotion?
Silly.
Yeah, silly, okay. Other words or labels? Aggressive, good, yes. You can see that we already have disagreeing opinions here, right? Actually, the label here is saying angry. So we can see that how the labeling could really mess up the accuracy of the training data, and that could be something interesting to communicate. So in our experiment, again, happy face versus unhappy face, but this time we focus on the labeling quality. So this is a low labeling quality condition because you can see that under the happy faces, some faces were really sad. I'm a mom of 2 little people, so I can tell that the girl is definitely not happy. Yes. And an anecdote is that we have to make 50% of the images in both conditions mislabeled so people can tell it's an inaccurate labeling condition, which is very weird because people are not really paying attention to those kind of stimulus these days. And we have another condition, which is high labeling quality. So the label match the images perfectly and accurately, 100% accurate. And we found that this labeling quality is very important. When people are seeing those high labeling quality, it makes them believe the training data is more credible, trustworthy, and reliable, and that leads to higher trust in the AI system. So that approach worked, focusing on accuracy of labeling. And that is our innovative approach. You may be wondering what the industry is doing. So I would like to show you the current practice that is called documentation. So the industry recommends that designers and developers document the training data characteristics before deploying the AI tool to the public for wide use. So this is an example from Google Model Card. As you can see that there is a bar graph communicating the characteristics of the training data. So if you're like me, I'm an Asian woman again, so I may pay more attention to the median skin tone and darker skin tone. I can see that is less represented in this training data, which means if this AI tool designed to detect faces, then it is likely to have less accuracy when identifying faces like me, right? So that is what Google Model Card will do. So we designed our own model card for a hypothetical AI tool. We call it Hire Me, which is a tool that can help classify a person's facial expression during interview videos. Because there are nowadays a lot of online interview platforms that are AI-powered. Even Elon has one, but I would like to tell you they're biased. So you would like to communicate to your students when you recommend the tools to them. So there are a lot of information. The left-hand side is saying that this AI tool has been trained on a large data set, and the right-hand side is saying that this data are labeled by volunteers before it trained for AI to use. And there are two important bar graphs I'm communicating here, which is about the percentage of facial images. In this case, you can see that the three racial groups contribute equally to this training data. That is what we call as showing racial diversity in the training data. And the right-hand side image is showing the percentage of labelers, which is, in this case, is about 92% of labelers are Asian. So is that an issue? Maybe or maybe not, but let's see some examples. So these two are real images from a huge data set called ImageNet. People have been using this data set for training AI to recognize objects. And if I say, how would you describe the left-hand image with just one or two words if you're going to label this image for our machine to learn?
Introspective.
Okay, yes, that's a good term. And what else? If more straightforward, yeah? Bride, yes, great. Yeah, thank you. So the label associated with the left-hand side image is like bride, woman, and wedding. Totally makes sense, right? And then, but how about the right-hand image? How would you label it? It's the same, right? I see some of you say, yeah, thank you so much for pointing it out. It's exactly the same. But it was actually labeled as art performance and the costume. Yes, so you can imagine like an AI trained on this type of images, they will have a hard time recognizing this beautiful Indian bride woman, right? Yeah, that's an interesting question because only 3% of their labels are Asian. More than 50% of their labels are from US and also European countries. For this data set, yes. Yeah, that was my study. Yes, but this is a real example. That was a hypothetical number from my dissertation study. Sorry about the confusion. But I want to give you more examples here because you may not really notice the influence. So is it decent or indecent? If you ask you to choose as a labeler. Yes, based on our context, our country, or location, yes, it's decent. But it was labeled as indecent because gay marriage was illegal by that time in India at the time of labeling. And how about this, funeral or marriage? Funeral? Why is funeral? Yeah, interesting. So this is a very special cultural phenomenon called crying marriage. The tears are not really indicating sadness, but also representing gratitude and respect because the girl is going to leave her original family and marry into her husband's family. So it will be hard for her to see her original family again. So it's a very special cultural phenomenon. So it's a marriage. Yeah. So you can see that our cultural background can really influence how we interpret the facial images, right? So that's why we're saying that the racial Yeah, so we're saying that the racial diversity in labor's background really matters. So after communicating all this information, we invite our participants to imagine themselves as human resources manager. They find a tool to just automate the hiring process, and they encounter a platform called Hire Me. And this is an online job interview platforms, and participants were told there are a lot of factors influence a person's employability, such as the word choice, speech pattern, but one of the most important factors is about the emotions. So this will indicate to what extent you are a good fit for the job, and that will influence how likely you're going to get the job. And we invite them to see a scenario where 3 young people competing for an entry-level job, sales assistant, and invited them to watch an interview video for each of these candidates, which is like less than 1 minute long. And we manipulate their background to be quite similar to each other. They all love meeting new people. They all love problem solving, which make them very good candidates for this position. And I would like to show you one example because we intentionally manipulated their tones and facial expressions to be neutral, and the only difference we want to highlight here is about their racial background. So this is an AI-made video, AI-created video.
I am Chen. I am a self-starter, energetic, and extroverted. I am a business administration graduate from Illinois State University. I like meeting new people and helping them solve their problems. I always wanted a job that allows me to meet people of different backgrounds on a daily basis. So, a sales assistant position sounds ideal for me.
Yeah, so it's AI created. Do you feel real or do you feel fake? Yeah, fake. But by that time, 2 years ago, it was considered really authentic. I would say AI advanced too fast. Yeah, as you can see that there is an emotion reader AI like sliders evaluating the emotion at the same time, and in this case, it's evaluating the candidates positively. So because they have the same background, everything pretty much the same. So if there's an unbiased AI system, then they should all be evaluated positively and be considered a good fit for the job. But if it's an unbiased AI system, which is a case in our experiment, we let the AI system favor the white candidates and downgraded the performance of the other 2 candidates, thinking their emotions either showing anger or fear, like matching the stereotypical thinking of these 2 groups. And by the end, half of our participants had the chance to provide feedback to the AI system, indicating to what extent they agree with the AI's classification outcomes, and if they don't agree, what's the actual facial expressions showing on the interview video. And our results are very, very interesting because we did this experiment with a large sample of participants and 1/3 from each of these racial groups. So it's considered representative training data, representative sample. And we found that you remember the 2 bar graphs we communicated earlier about racial diversity in training data and the racial diversity in labor's background. They are equally important, and they can make people believe the training data is diverse and shape this expectation that the algorithm performance is going to be fair and further leads to higher trust in AI in all 3 dimensions. And this outcome works equally well for both white and non-white candidates in our participants in our study. We proposed this user feedback, which is the last step user did with our experiment, as a way to restore people's trust in AI when they encounter biased AI system. But that was not the case, as you can see here. When it's biased performance, providing feedback or not didn't really do much to improve the behavioral trust, which is the intention to use this AI system in the future. But actually, when the AI performance was unbiased, providing feedback opportunity actually lowered people's trust in AI. So that's interesting because that's a usability issue. Some of you may think if AI is doing a great job, then why bother correcting them or giving them feedback? It's just a waste of time and money and resources, right? So we did this testing and we found that only white participants in our sample thought that way, but it's not the case for non-white participants. They still believe there is a value of correcting and giving feedback to the AI system when it shows good performance, because that is about positive reinforcement and can just reinforcing AI is knowing what is the good performance in the future. Yeah, so this line of research is very, very important because currently the dominant approach in explaining how AI works, emphasizing post hoc explanations. there are a lot of characteristics defining what is post hoc explanation, but one most important characteristic is about they always present the explanation after the AI's performance. In our study, we're arguing that it's too late because it significantly increases people's cognitive overload when they're encountering a biased AI system. People were wondering, what's wrong with the AI system? Why is biased? So explaining after a performance is just not a good timing. That's why we're highlighting that, showing the pre-explanation that is before the AI's performance could potentially be better. And in our study, we're showing that, showing this pre-explanation, especially when AI performance is biased, actually reduced people's cognitive overload, and that leads to higher understanding of how the AI system works. So that is a great advantage of having early communications in human-AI interaction. So now, I'm also a teacher here, not just a researcher. So whenever I would like to talk about algorithmic bias to my students, I would like to incorporate these examples. This is a publicly available tool called Teachable Machine. And what you can do is that you can train the AI to differentiate two objects. For example, I was training this AI to differentiate males from females. And what I did is that I uploaded 6 example images for each category. And then I click training and open my camera and let it to identify my faces. But, oopsie, it seems like thinking I'm more likely to be a male. What's going on? So I tested again. I feel like probably it's about my hair. So I put my hair down. Okay, now I'm more likely to be a female. And I did again. Hair up, then I'm a male. So what did the machine learn here? You probably all know the length of your hair, right? But is it a good indicator to differentiate women versus men? Probably not, right? So you can see that my training data is problematic. That's why I need to add more diverse training data showing variety of hair length to make sure it understands the difference more nuancedly, right? So that is a tool I often show to my students, and they had a lot of fun, like differentiating celebrity versus just lay people, where people like having different facial expressions, where people who wear glasses or not. So you can try this tool with your students, and it's very easy to find those images on databases like Google Photos, so that would be a good tool to use. Yeah?
There's probably only male, female.
And you can do more, like more categories as long as you want to differentiate. Like in this example, they're trying to differentiate marshmallow versus non-marshmallow.
But just within gender,
Yes.
the only gender identifiers they allow.
They allow more. You can add more class, but just for an example, I did a like binary option, but I'm aware there are more options here.
I
Yeah.
did a few training, and I showed examples in my class too. One of the examples I just trained attentiveness in the class. Show a video, if you're watching and checking your camera, I can detect. And it kind of will work a little bit. And students say, oh, cool, I need to be attentive, not checking my phone.
Yeah.
You can train anything, any class.
That's great. Yeah. So hopefully you can use this tool in your teaching, and hopefully that's going to be a fun experience for your students. And now we're just not talking about traditional AI. We have a variety of AI. They have a new name called generative AI. They're new because they're designed to generate new content, such as text, video, audio, and images. And you may be wondering how biased is generative AI. So here's a report saying that if humans are biased, generative AI is even worse. So how did they figure it out? So they tested a tool that is called Stable Diffusion, which is like an image generation tool, kind of like ChatGPT. And they prompt the tool to generate image for different occupations. In this case, it's about cashiers. Generate the image 60 times. So here's what we get. Ooh, the cashier seems like it's mostly female and people of color, right? But now if we're thinking about CEO, what kind of image will you get 60 times? White guy, right? Yes, you're right. Yeah, that's the bias. It's talking about here representational bias, showing stereotypical thinking towards certain occupations. And previously, we were talking about, communicate the training data, because that's the key that leading to algorithmic bias. But here, we encounter a challenge here, because large language model is trained on a huge set of training data. It's like the whole universe here. It's very hard to communicate the characteristics of training data to lay users. So what we're going to do here is that we introduce the new approach to communicate algorithmic bias and hopefully to increase people's awareness of this issue. And this approach is called inclusive prompt coaching. So what we did is that we designed our new image generative AI tool called Inclusive Art AI. And just like ChatGPT, you can describe what you would like to draw, and the AI will produce the image for you. But before it generates the image, in this case, it's a panda eating hot pot, we provide a little bit intervention there. So the intervention first is about alerting user to the potential bias in AI, especially the text in the yellow box saying that AI may produce biased or stereotypical output based on user's input. And the follow-up is a little bit explanation showing that it's good, panda eating hot pot, but those are symbols just about China. So you could reinforce like simplified or reductive view of Asian culture. That's why it's not considered very diverse. And then the AI generated a prompt for me to consider, saying a panda enjoying a hot pot meal, embracing the joy of diverse culinary experiences. So asking me which one I would like to adopt for the final image generation. So that is the intervention we're talking about here as inclusive prompt coaching, right? And through this process, we found out that this approach is very effective because it significantly increased people's awareness of algorithmic bias and also made them believe they are more confident in writing the appropriate prompts to reduce bias in AI system. But also it comes with some limitations because it results in reduced perception of helpfulness, making people believe the tool is less helpful, and also making people believe it's more frustrating because of this like extra steps people have to go through before seeing the image. So our next step would be focusing on how to make sure it is both like persuasiveness and also useful at the same time. But our follow-up question is that, does inclusive prompting yield results that are indeed more inclusive? So we actually went into the prompts user created by themselves and the AI suggested prompts based on the user's like initial input, and we're comparing the image differences before and after inclusive prompting. So I don't know whether you can tell or not, but I personally just feel the right-hand side image is probably less stereotypical compared to the right-hand side image is probably less stereotypical than the left-hand side one. But we will compile like all the images and compare them in our follow-up study. I don't have any results to share with you so far, but that's the next step we're going to do. And this is another example of a fish playing soccer. I'm not an expert in identifying diversity in fishes, but hopefully, yes, it aligns with our hypothesis that is this inclusive prompt coaching works by bringing more diverse image. Yeah, so what my research is doing is that I'm focusing on AI affordance. The latest one is about prompting, but there are many other affordances of AI to communicate racial bias in AI algorithm. And this approach is going to be very fruitful because it's widely used on AI interfaces. It's either manifest as cues, that is you commonly see when you're interacting with your own AI tools, like memory updated, thoughts for a couple of seconds, AI is generating. This is made by AI. You don't have to really interacting with it to know. It's just a message like showing on the interface, communicating how the AI works or how the AI doing its own thing. And the other part is that it could also be manifested as an action. So the first one is from DeepSeek. You can turn on the deep thinking mode to engage more about the reasoning aspects of the AI. You can generate the image. You can also clear memories to protect your privacy. So there are a lot of user actions you could engage on the AI system as well. And based on the theoretical model called high time, so they're proposing that this cue and action will have totally different effects. So when you're just seeing the AI thinking for a couple of seconds, maybe you think the AI is putting a lot of effort, and this effort heuristic will reshape your perception and trust in AI, probably leading to higher trust in AI if you believe AI is putting more effort than you expected. But when you engage with it, that is turning on the deep thinking mode, probably will give you a greater sense of agency, making you believe that you have control over the action and consequence of the AI tool, and that will like to lead to different perceptions and trust in AI. So my study is using this model to test a variety of perceptual and behavioral outcomes of human-AI interaction. And by using this approach, we're not just seeing AI as a whole, but looking at the specific features, affordance, and message inside of this box. And this variable center approach is really beneficial for knowledge generation. And I believe this affordance approach will not only help with communicating algorithmic bias, but also help solving AI and the environmental impact, help calibrate more appropriate trust with AI systems, and also help debunk misinformation when people interact with AI system that could making things up. Yeah, so hopefully we will all focusing on design more trustworthy, ethical, and sustainable AI systems that not only serve users' needs, but also protect their welfare. And that's my goal, and hopefully that is a shared goal of people who are interested in AI. Thank you so much. That's the end of my talk, and I'm looking forward to your questions, and thank you so much.